Hello students, welcome to Study It Out. This question is from Physics chapter Ray Optics. In the question it is given that a person with a normal near point 25 cm using a compound microscope with objective of focal length 8 mm and an eyepiece of focal length 2.5 cm can bring an object placed at 9 mm from the objective to sharp focus. What is the separation between the two lenses? This is the first part of the question. And in the second part, we have to calculate the magnifying power of the microscope. So in this question, we have two subsections. In the first part, we have to find the separation between the lenses. And in the second, we need to find the magnifying power of the microscope. So let's solve this question. This is our compound microscope. Here is the objective. This is objective and this is our eyepiece. Object is placed, this is the object, and according to the question, the distance of the object is given as 9 mm. If these two rays will meet at a point, let's take here it is meeting. So at this point, the image is formed by the objective. So we can mark this distance as VO. And now this distance is our object position for the eyepiece. So we can represent it as UE. The final image is formed at this point. So this is the distance of 25 centimeter or normal near point. So let's note down the given values. So here D is equal to 25 centimeter. FO, focus of the objective, is 8 mm equal to 0.8 centimeter. FE is equal to 2.5 centimeter. UO is 9 mm equal to 0.9 centimeter. And we have to find the separation between the two lenses. So this is the separation between the two lenses and it is equal to x. So here we have to find the value of x, and in the second part we need to find the magnification. So first we will find the value of x. So to find this x, we need to find the value of VO and UE, because this lens distance x is actually the sum of the distance of VO plus UE. So in the question, VO and UE is not given. We need to first find it. So let's find the value of VO. So we can use the lens formula. 1 by FO is equal to 1 by VO minus 1 by UO. And further substitute the value. In the question, FO is given as 0.8 mm. FO and FE both sign convention is positive. This is positive sign convention. UO will be negative and this D is also negative. So it is equal to 1 by VO minus 1 by minus 0.9 centimeter. So 1 by VO is equal to 1 by 0.8 minus 1 by 0.9. 1 by VO is equal to 10 by 8 minus 10 by 9 is equal to 72 LCM, 90 minus 80 equal to 10 by 72. So VO is equal to 72 by 10, it's equal to 7.2 centimeter. So VO value we got it. Now we have to find the value of UE. So to find the UE, we use the same relation. Again the lens formula, but this time with respect to eyepiece. So 1 by Fe is equal to 1 by Ve minus 1 by Ue. 1 divided by 2.5 centimeter is equal to 1 by Ve is our near distance. It's equal to minus 25 centimeter minus 1 by Ue. So 1 by Ue is equal to minus 1 by 25 minus 1 by 2.5. So Ue is equal to minus 1 minus 10 divided by 25. Ue is equal to minus 25 by 11 centimeters. So approximately minus 2.27 centimeter. So now we know the value of Ue and Vo. So here x is equal to Vo plus Ue. So we can say x is equal to 7.2 centimeter plus 2.27 centimeter. Sign convention is not required because we are just measuring the distance. It's equal to 9.47 centimeter. So this is the answer for the first part of the question. Now we have to find the magnification. Magnifying power m is equal to magnifying power of the objective into magnifying power of the eyepiece. So m is equal to Vo by Uo bracket 1 plus d by Fe. This is the magnifying power for the near point. So let's substitute the value. M is equal to 7.2, that's the Vo, divided by 0.9 bracket 1 plus 25 divided by 2.5. So M is equal to 8 bracket 1 plus 10. M is equal to 8 into 11. So magnification is equal to 88 times. So this is the answer of the second part of the question. If you have any doubt, you can mention it in the comment box. I will try to resolve it. Thank you so much.